our final measurement is looking at stone roundedness and stone size, and we would expect this to change downstream. So in your upper course, you're looking to find really quite large angular rocks. By the time you get to the middle course, they're going to be a little bit less angular, a wee bit more rounded, and a lot smaller, and that'll continue downstream. And the reason for that is because of erosion. So at the top of the river in the upper course, the rocks have fallen into the river, most likely from freeze-thaw weathering, and they haven't been eroded yet. However, by the time they get moved down to the middle course, they've experienced a lot more erosion, and that's mainly through the process of attrition. Now that will continue further downstream as you enter into the lower course, where you would really expect to find very small rocks that are very, very round. So I'm going to take a sample of rocks from this particular point, and as I say, I'm really in the middle course at this particular point. Now, to gather your stones, you have to just select at random. So you have to go into the river, and you literally will just choose 10 rocks that your hands first come across. Now when I've done that, I will bring you the stones that I've found, and I'll show you what to do in terms of measuring them after that. I've been into the river now and I've collected my 10 different rocks. Now I would expect round about the middle course of the river where I am to find a mixture of rock sizes and shapes, and that's because they've not been travelling down the river that far, so therefore they're not going to be as eroded as I would expect them to find in the lower course. So in the upper course you would expect the rocks to be very large and you would expect them to be very angular. And in the lower course, you would expect them to be very small and very rounded. So as I say, I'm in the middle course and my sample is definitely quite mixed. So what do we do with this information then when we have it? So this is one of my rocks, and I'm going to measure the length of the rocks. Now in order to do that, I'm going to need either a ruler or a pair of calipers. Now I have a pair of calipers with me, and these are digital calipers, which makes my life a lot easier. Now I need to measure the 3 different axes of the rock. So the first one is the A-axis, and that goes from the top of the rock to the bottom. That's just the length of the rock. Then you want to measure the B-axis, which is going across the rock, and finally the C-axis, which is the width of the rock. Now if you do that for all 3 axes, you're getting a really good understanding of what the bedload size is like. If you're a wee bit restricted in time, then probably the best axis to measure is your A-axis, because that's the length, so it's kind of showing you the size of the rock. So I'm going to take my calipers and I'm literally just going to place my rock inside, and I'm going to take a reading on that. And in this case, we're looking at this, the A-axis of this rock is 9.6. Now I'm going to record that on my record sheet. Then I'm going to measure the B-axis, and the B-axis is the diagonal length, and in this case we're looking at about 7.8 centimetres. And again, I'm going to record that on my record sheet. And then finally I'm going to measure the C-axis, and that is just the width of the river, and I've found that this particular width is 6.3, and again I'm going to record that onto my record sheet. Now when I've done that for all 10 different rocks, I'm going to work out the average size of the rock. Now I'm going to do that for all 3 of the axes. So to do that, I need to add up all of my different measurements, and then I have to divide it by the number of rocks that I've measured. So in my case, I've measured 10 different rocks, so I'll divide that by 10. And that will give me the average size of the rock on its A-axis, its B-axis, and its C-axis. Then I need to measure the shape of the rock. Now, as I said already, I would expect the most rounded rocks to be in the lower course, and I would expect the most angular rocks to be in the upper course. I'm in the middle course, so again I would expect them to be all different shapes and sizes really. So if I take my first rock here, you can see that it is quite angular. It's not very rounded, although the edges are quite smooth, which kind of prove that it has undergone some form of erosion, most likely attrition. It's not fully rounded yet, so therefore I need to think of what category that is going to fit into. Now in order to measure the bedload shape, we use the Powers Index of Roundness, and this is basically a scale going from 1 to 6. 1 being the most angular, 6 being the most rounded, and it's really just an estimate of what you think this rock fits into, which category. So I'm looking at this rock and I'm probably going to place it round about a category 3. It's not very angular, but it's certainly not very rounded, so I think a 3 is probably a good estimate for this particular rock. Now I'm going to record that down on my record sheet. Now when I've done that for all 10 rocks, again I'm going to work out the average. And then in the same way as I did before, I'm going to add up all of my different categories and then I'm going to divide it by 10, and that will give me the average bedload shape. Now when you're doing this, especially if you've come down here to carry out your investigations with a friend, it's probably best that one of you decides which one is going to estimate the bedload shape, because this is really just an estimate. So your interpretation could be a little bit different from your friends. So if you have started measuring the bedload shape, I suggest that you do it for all 10 rocks and probably in all 3 sites, and that will give you a much more accurate result. So once you've done all that, you've gathered all your information and you now know what the bedload size is and the bedload shape is for the middle course of the river, and you will repeat that for the upper course and the lower course.